All right, here we go. Question number 3 from our pre-calculus homework number 3 in MyLab Math. This time we have matching. We're going to have to match the equation to the appropriate graph. We're going to start with what we would refer to as the parent function. Y equals 8 to the x. If you think back to when we covered graphing with transformations, this particular equation right here would have no transformations. So if we take a look at this in our scratch work, y equals 8 to the x, we can plug in a couple of easy numbers to work with to get an idea of where the graph is going to go. If x is 0, that would give us 8 to the 0, which is 1. And then 8 to the first power is 8. So we know that this graph is going to go through the y-axis at 1, and then when x is 1, we're going to be way up here at 8. So this graph is going to come over and curve up like so. Every exponential curve is going to have a horizontal asymptote. That is the line that the graph approaches but never touches. And here we can see that this is an understood positive 8. Then that curve will curve up to the right. So now we need to just pick the graph that looks like this as close as possible. Okay, so 37, this is not correct. It curves the wrong way. 38 doesn't go through the y-axis at 1. 39 curves down. So does 40. Okay, next, 41 looks promising. This one goes through the y-axis at 1, and it looks like it's going to hit 1, 8 right there. So I'm thinking that this equation is going to associate with number 41. But let's keep looking just to make sure. 42 curves the wrong way. Now, number 43 curves up, but notice it goes through the origin, not through a y-intercept of 1. 44 curves the wrong way. So now I think I've talked myself into 41. So we're going to click and drag this guy down to number 41. And then notice it takes that away from your choices so that you can see what's remaining. Now the next easiest equation here to look at would be y equals negative 8. If we do the same substitution for 0, negative 8 to the 0, that's going to be negative 1. The reason it's negative 1 is because the negative 8 is not in parentheses. If it was, that would be positive 1. And then 1, anything to the first power is itself, so that'll give us a negative 8. And then if we go to the xy coordinate system, we can see that we're going to have a y-intercept of negative 1. And when x is 1, we're going to be way down at negative 8. So this curve is going to look something like this. Okay, again, if you think back to your transformations, having a negative in front of the function is going to do a vertical flip, flipping the original graph across the x-axis. So here we have the exact same graph we just looked at, but reflected across the x-axis. And so now we just need to find that graph. So we're looking for a graph that curves down, something like number 40, but number 40 goes through the origin, not negative 1 for a y-intercept. So notice number 42 does curve down like we expect. It is going through a y-intercept of negative 1. And when x is 1, it looks like it's going to be at negative 8. So I think 42 is going to be this equation. So we're going to take y equals negative 8 to the x, drag it down to number 42, and drop it. The next easiest equation, I think, to graph here is going to be y equals 8 to the negative x. If we do our same ordered pairs, 0 and 1, well, you can't have negative 0, so that would be 8 to the 0, which is 1. But plugging in positive 1 will turn that into negative 1, which would give us a y value of 1/8. And if you're wondering how I got that, it's from the calculator. Plotting those points, 0, 1 is our y-intercept. And then if I'm at 1, I'm at an eighth, which is barely above the x-axis, which indicates an exponential curve coming in like so. So, from our remaining graphs to choose from, we need to look for the curve coming in like so with our y-intercept of 1. And that looks a whole lot like number 37. Coming in the way we expect, it does hit the y-axis at 1. So we're going to take that equation, y equals 8 to the negative x, and drag and drop it for number 37. And I actually had to zoom out some because it wouldn't let me drag and drop it. So here we go, drag and drop, bam. All but one of these has a shift. I think the next easiest equation to match up would be y equals negative 8 to the negative x. So again, if we go back to our table of values and plug in 0, we're going to get negative 8 to the 0. Remember, anything to the 0 is 1, so that's going to be negative 1. And negative 8 to the negative 1 would be negative 1/8. So sketching a quick graph of that, we can see a y-intercept of negative 1. And when x is 1, we're at negative 1/8, which is barely below the x-axis. And so that curve is going to do something like that. So again, we're looking for a curve that curves up from the left, going through the y-axis at negative 1. And looking at number 39, we do have a graph coming up from the left, going through the y-axis at negative 1. So I am pretty sure that 39 is going to be our option for that graph. Again, I'm going to have to zoom out so that I can actually drag and drop it into that box. All right, so the rest of these graphs are going to have shifts, either vertical shift or horizontal shift. Also keep in mind that I have limited graphs to pick from now. All right, next equation, let's look at y equals 8 to the x minus 1. Again, I'm going to use my two x's that I've been using to try to nail down some points. If I plug in a 0 and actually show my work this time, 8 to the 0 is 1, 1 minus 1 is 0. So now we need a graph that goes through the origin. And if I plug in a 1, 8 to the 1 is 8, 8 minus 1 is 7. So these are the ordered pairs that I'm looking for on the graph at this point. Going through the origin, curving up to the right, going through the point 1, 7. Now, number 38 hasn't been answered yet, but number 38 doesn't go through the origin because you can see the asymptote, the dotted line, is on the x-axis, meaning that the graph will never touch the x-axis, so it can't touch at 0. Number 40 does go through the origin, but it's going to be at the wrong y value when x is 1. We need a graph that curves up to the right, not down to the right. Number 43, now this one does go through the origin, and it is curving up to the right. Look at that. It looks like it does go through 1, 7. So I bet 43 is the one we need. All right, so we're going to drag and drop our y equals 8 to the x minus 1. Drag and drop that down for number 43. And the next easiest graph to look at, I think, is going to be this one, y equals 8 to the x minus 1. Since the minus 1 is up in the exponent spot, that is going to be a horizontal shift to the right. So we need to look for a graph that looks exactly like 8 to the x shifted to the right 1. So again, here's our y equals 8 to the x. If I shift that to the right 1, then what was the y-intercept now will be at 1, 1. And it can't be 44 because this one curves the wrong way. So we need a curve going up, but going through the ordered pair 1, 1. And there it is. Number 38 is going to be the graph for our equation of y equals 8 to the x minus 1 with a horizontal shift. And I had to zoom out again so that I could drag and drop that in there. All right, we've only got 2 more equations to graph. Let's go ahead and take care of this first one where we're going to have a vertical shift up. Let's find the graph that represented negative 8 to the x, and we'll shift that up 1. All right, so here is our graph that represents y equals negative 8 to the x. If I shift that up 1, we're going to be looking for a graph that curves down to the right, and the horizontal asymptote shifted up 1 space. And that looks a whole lot like number 40, where we're curving down to the right and the asymptote is shifted up from the x-axis. So this equation is going to have to go here, and by the process of elimination, our last equation has to go here. And that's going to do it for that particular problem. So if you have any questions or comments about anything covered, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.